So we're going to talk about tangents, and don't think tangents from math 2. We're going to talk about tangents on circles. And this particular tangent, this line only touches the circle at exactly 1 point. So it is outside of the circle and only touches at 1 point. All right, so if you look at numbers 1 and 2 at both point A, that line outside of the circle only touches at 1. So like if we extended it, that's what it's talking about. That line is tangent to the circle because it is outside and it only touches at that 1 exterior point. Everybody got it? So that's all that tangent means in this. It's not math 2 where it's opposite over adjacent, anything like that. We're not working with triangles, okay? So what we're looking at to determine if there's tangent or not is to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And that's because a radius and a tangent makes a 90-degree angle. So right here, a radius and a tangent line makes that 90 degrees. On number 2, the radius and the tangent makes the 90 degrees. And I'm actually going to start with number 2 because number 3 is number 1 is one extra step. So we're going to look at this one. So remember, either leg is going to be A or B. It does not matter. You can switch those up. So either one could be A or B. The one that's important is the one that's across from the 90 always has to be C. Okay, your longest side is always going to be C. So again, across from the 90 is your C. So we're going to set this up in the Pythagorean theorem. 17 squared plus 12 squared. And again, those are interchangeable. Equals 20 squared. If this comes out to be true, the left is equal to the right, then it is in fact a tangent line. If it does not, then it is not a tangent line. So we're going to put in 17 squared plus 12 squared, and we get 433. When we put in 20 squared, we get 400. They are not equal, so this line is not tangent. Not equal, so not tangent. So that one's really cut and dry, has all 3 measures perfect for you. If we look at the next one, we need all sides. So AB is 4. We need the full length of the side. How long is this one? 5. We have to add those up. Everybody good with that? Add those up. But then I don't have a measure for this side, but I do. How long is that side? Use what they give you in the problem. What is this? This line from the center to the outside? Why? It's a radius, and this 3 is also a radius. So we know that this side is 3. That's the most that you'll have to do. Okay. So add up a side or check out another radius. So remember, your longest side is C. The other 2 do not matter. So I'm going to do 3 squared plus 4 squared and see if that equals 5 squared. If you know your rules, you should know that a 3, 4, 5 triangle is perfect. So 3 squared plus 4 squared is 25. And 5 squared is 25. So since they are equal, that line is tangent. So it'll be a yes. So if it's multiple choice, it'll be yes. On the next one, you're just trying to find out, like on 3 and 4, the length of the segment. They are tangent, which means that they form the 90-degree. So we're still using Pythagorean theorem. So again, our C is the side across from it. I know that this is going to be X, but this is not the full length. This is just from the outside to this point or this vertex on the triangle. How much is this part? 6.6. Right. So now, just to reference it, it looks like number 1. The only difference is instead of a 2, we have an X there. Everybody see that? How did we find the full length of this side? We add them up. So that's what we're going to do on this side as well. We're going to add them up. So we're going to write X plus 6.6. And again, that's our longest side, so that's going to be our C. So we're going to do A squared plus B squared equals C squared. Sorry, I squished that in there. I'm going to tell you the easiest way. Do not square this. Do not square this. Does everybody understand? Just leave it alone for right now. We're going to put this into our calculator. 6.6 squared plus 11.2 squared, and we're going to get 169. And then to save me some trouble, how do I get rid of a square? Square root it. So we're going to square root both sides. Now we need to remember that when we square root, we have 2 answers, a positive and a negative. Sure. Thank you. After class, please. All right, remember it's a positive and negative 13, so I'm going to split this into 2 equations, a positive 13. I'm going to solve it. So we're going to subtract 6.6. And we get 6.4. Since this is a measure, it has to be positive. Okay, since this is a specific measure, it has to be positive. So this one's going to work. The other one may not. We don't know. I'm going to set it equal to negative 13. So negative 13, I'm going to subtract 6.6. What did it give me? A negative. Can I have a negative measure? So this is an extraneous solution. So your only answer is 6.4. But yes, you have to do both of them. Sometimes both of them will work. Okay, it will not always be one will and one won't. All right. Look at your next one. I have the full length of this side. All of this is going to be X. See how they made it stretch out like that? That's how you'll know if you have to do it this way or if it's automatically all of it X. I need all of this side. What is all of that side? It's not 3. 3 is just this side. Why is it 6? It's a radius, makes a diameter, so both sides are 3, which makes a total of 6. So there are your measures, 6, 4.5, and X. Remember, across is going to be whatever your C is. So we're going to do 6 squared plus 4.5 squared equals X squared. 6 squared plus 4.5 squared is 56.25. How do I get rid of the square? Square root it. And I get X equals, remember there's a positive 7.5 and a negative 7.5. Since this is a full measure, we can't have that one, but can only have the positive. All right, so I know it seems pointless to keep doing both because one of them gives you a negative. However, if this turned out to be like x plus 10.2 and you're trying to solve it for this, x could be negative because it makes the whole measure positive. Okay, so just make sure that we're looking at what the measure is. All right, hopefully we'll get one of those. I don't know if we will. All right, so perimeter is the easy one. I call this the ice cream cone theorem. You know, in geometry, you have theorem 2.6 or something like that, okay? So this is a theorem. I do not know what number it is. I honestly, not being ugly, like I honestly don't care that you know what number it is. I just call it the ice cream cone theorem. So what that means is, if we look at this and I take off like these two corners, you guys see how it kind of like this would be your ice cream and this would be your cone, right? So when we eat ice cream, we want our cone to be level because if it's sideways, it's going to dump our ice cream out when it melts, right? So what you need to realize is these two sides have to be equal, otherwise we're going to spill our ice cream. So that's why I call it the ice cream cone theorem. So if we're looking right here, if this side is 8.6, what is this side? It's got to be 8.6. So that's why, again, you just got to make it equal. All right, if I flip it this way, I don't have those two measures, but I'll be able to find them. So I go to this side and see how this total is 20.6. I know that this part is 8.6. So how do I find this part? Okay. So to find this half, I'm going to do 20.6 minus 8.6, which is what? 12. So if this side is 12, what is this side? 12. So this little part is 12. If all of this is 18.4, how do I find this part? Subtract it, 18.4 minus 12 gives you what? 6.4. So if this little part is 6.4, what is this little part? It will always work that way, okay? So ice cream cone theorem. Now, what does perimeter mean? Add all the sides, right? Or add the outsides. Right. So we have two 8.6s. We have two 12s. And we have two 6.4s. Can you make that shorter? Sure. You can use 20.6, 18.4, 6.4, 8.6. I don't care how you get the outside. I just do it double so that you can see we got to get every part. So 8.6 twice, 12 twice, and 6.4 twice. It gives us a total of 54. Any questions? Okay, flip it over. Doing the same thing, find a singular side. So what I mean by that is find one of the little parts. This is a total, this is a total, this is a total. So this matches with this little part right here. So what is this side? 10.1. How do I find the other part right there? 18.2 minus 10.1 gives us 8.1. So that means this part is 8.1. How do I find this part up here? 21.1 minus 8.1. What do we get? 13. So that means this part is 13. How do I find this little tiny part down here? 18.4 minus 13. Ooh, sorry. Gives us what? So then what's this little part? Right. So then we just go around. I'm gonna start where I started at the beginning of the problem. I have two 10.1s. And then I got 8.1, so I have two of those. And then I got a 13, so I have two of those. And then I got a 5.4, and I have two of those. You don't have to write all that down. You can just add it up. I just want to show you where it's coming from. I got two 8.1s. I got two 13s. I got two 5.4s, which gives me 73.2. Any questions? Find a singular part on this one. Which one is a singular part? There's actually a lot of them. 6.5 is the little part. So that's this part. So this part's going to be 6.5. How do I find this part? (15.2) minus 6.5 gives me 8.7. So this side is 8.7. What's this side? 7.2 because it matches the other side. I have 13. What's this side? 13. So add them up. I have two 13s. I have two 6.5s. I have two 8.7s and two 7.2s. So 13 plus 13, 6.5, 8.7, and 7.2 gives me 70.8. Any questions? All right. Look at your next one. It's the same thing. They just like this measure and these don't matter. You guys see the ice cream cone? Remember those two sides are going to be equal. So we're going to set them equal. I'm going to do it down at the bottom. 5x minus 2 equals 4x plus 1. I always move my x's first and I always move the littlest one. So I'm going to subtract 4x. That gives me x minus 2 equals 1. Add 2, and I get 3. It said solve for x, so we're done. The worst thing they might do is ask you to plug it back in and find the measure. Okay. All right. Ice cream cone again. We're going to set them equal. 5x plus 4 equals 6x minus 1. I always move my smaller x. I'm going to subtract 5x. I get 4 equals x minus 1. Add 1, x equals 5. And again, on number 10, you're doing the same thing. They try to give you things that make you think harder than what you need to, so none of this is needed. We just need these two. So set them equal. X minus 7 equals 2x minus 16. I move the smallest x. That gives me negative 7 equals x minus 16. Add 16. And I get x equals 9. That's literally it. Like it does not get any harder than that. Okay. Everybody good? Your quiz follows right through your notes. So if you keep your notes out, you should be able to figure it out. If there's any that are crazy, just ask me and I'll help you. Okay. Any questions? Was everybody okay with yesterday? Sort of, maybe, yeah. If you have any questions on that one, let me know too. Okay. All right. Everybody good? All right. I'm going to stop sharing, stop recording.